Okay, in this question we're looking at the radioactive material of strontium-90 uh, and the decay of it. So this strontium is actually not the same that you get from pharmacies where it's actually a good supplement for bone improving bone density. So I've written in advance the rate of change of a material. So this is any material. So n being the amount of material, so dn per dt is the rate of change of that material with time, is equals to a constant times the material amount at that moment. Negative lambda here, uh, it's given as negative because in this case the rate of change causes the material to decrease. You can also derive the equation of n equals to n naught e to the power negative lambda t. Okay, for this question, if we were to calculate the decay constant of strontium-90, we need to have some information, and that information has been given to us. So we're actually given the half-life of the material, so T half. So this means that when T is, so half-life of the material, when T is about 29 years, the material halves, so N becomes half N naught. So when we substitute this into the equation, so what we get is half N naught equals to N naught E negative lambda T half. So we can see from here we should be able to calculate the value for lambda, but let's proceed on. So I can actually cut out N naught. So what happens is I have ln 0.5 equals to ln e to the power of negative lambda T half. So this actually gives me negative lambda T half equals to ln 0.5, and therefore if you calculate out lambda with a calculator, lambda equals to 0.0239 per year. Okay, so you have to use T at the half-life of 29 years. Okay, in the answer is put as seconds, so all you have to do is just convert your units, so 0.0239 per year. So I want to get rid of year, and I want to have it in seconds. So 1 year has 365 days, has 24 hours in a day, and 3600 seconds. So this should give you the answer of 7.5786 times 10 to the power of 10, sorry, negative 10 per second. Okay, so next part B. So what we're looking here is when n becomes only remains 1%. So when n equals to 0.01 n naught, so n naught is the initial material, what is the time? So this is what we want to look for. What is the time? Okay, so what we can do is again use the equation, but this time we know the decay constant lambda. So 0.01 n naught equals to n naught e negative lambda t, cancel n naught, so log 0.01 equals to ln e negative lambda t. So I can actually find, okay, negative lambda t equals to ln 0.01, so t equals to ln 0.01 over negative lambda, and if you calculate out, your answer should give you about So you can use lambda as years since the answer is giving us in years. So ln 0.01 over negative 0.0239, which gives us about 192.7 years.